Hello guys, so welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is the last day for the last chapter of the course, Exploratory Data Analysis in Python. So what we've learned so far over the last 3 chapters in the course, we've gotten to know the data sets, we've learned how to do data cleaning, data manipulation and interpretation, and how to deal with missing data. We've also learned how to understand the relationship between each columns in our data set. So what is the next thing to do after you've known all these three key techniques? So the last thing is to know how to turn your exploratory analysis into action. Now it's need to learn the techniques and consideration you can use to successfully to move forward in your project and build absolute, insightful, and amazing reports from your data set in Python. So without further ado, let's jump back to the learning and learn how to finalize after exploring all our data set that we inherit from anywhere in the world. So let's get started. So I just start sharing my screen real quick, so we can continue from the exploratory data analysis after we learned how to get to know the data sets, deal with missing data, data cleaning and importation, then build relationship between each column in the data set. Finally, what do we do next? Let's find out. So let's continue from here. Hold on a second. Okay.
Let's see how we convert exploratory data analysis into action. We'll start by looking at class frequencies. Recall that EDA is performed for a variety of reasons, like detecting patterns and relationships in data, generating questions or hypotheses, or to prepare data for machine learning models. There's one requirement our data must satisfy regardless of our plans after performing EDA. It must be representative of the population we wish to study. For example, if we collect data with the aim of analyzing the relationship between education level and income in the USA, then we would need to collect this data from adults residing in the USA and can't rely on data from residents of France. With categorical data, one of the most important considerations is about the representation of classes, which is another term for labels. For example, say we collect data on people's attitudes to marriage. As part of our data collection, we find out their marital status with the classes including single, married, and divorced. When we perform EDA, we realize only 50 people were married, while 700 were divorced and the remaining 250 were single. Do we think that this sample accurately represents the general public's opinion about marriage? Are divorced people more likely to have a negative view towards marriage? This is an example of class imbalance, where one class occurs more frequently than others. This can bias results, particularly if this class does not occur more frequently in the population. We've been counting the number of observations per class using pandas.value counts, like here, where we see how many flights went to different destinations in our planes dataset. Say that we know 40% of internal Indian flights go to Delhi. We can use value counts method again, but this time set the normalized keyword argument equal to true. This returns the relative frequencies for each class, showing that Delhi only represents 11.82% of destinations in our dataset. Again, this could suggest that our data is not representative of the population, in this case, internal flights in India. Another method for looking at class frequency is cross-tabulation, which enables us to examine the frequency of combinations of classes. Let's look at flight route frequencies. We'll start by calling pandas.crosstab function. Next, we select the column to use as the index for the table, in this case, the source. Lastly, we pass the destination. Values in this column will become the names of the columns in the table, and the values will be the count of combined observations. We see the most popular route is from Delhi to Cochin, making up 4,318 flights. Say we know the median price for all internal flight routes in India. Here they are for the routes in our dataset, measured in Indian rupees. We can calculate the median price for these routes in our data frame and compare the difference to these expected values. We do this by adding two keyword arguments to pd.cross tab. We pass the price column to the values argument and use agfunc to select what aggregated calculation we want to perform. We can pass a summary statistic as a string, in this case setting it equal to median. The results show median values for all possible routes in the dataset. Comparing our prices with the expected values, most are similar. However, routes from Bangalore to Delhi and New Delhi are more expensive in our dataset, suggesting they aren't representative of the population. Now it's your turn to look at class frequencies.
Okay, so let's practice class frequencies. So I have my data sets here. So I love to practice in Jupyter Notebook. You've been following me for a pretty long time. So these are the chapter 1, chapter 2, and chapter 3 of the course. I'll just go ahead and create a new file for the chapter 4 of the course. So this is chapter 4. So I'll just go ahead real quick and create a new notebook. I'm doing the last one first. So I can copy, let's name it EDA. Hold on. Copy this VDA for. So my usual libraries, I just copy that. Then, so I don't know the data point I'll be using yet. Just hold on a minute. So checking for class imbalance. So the 2022 Cargo survey captures information about data scientists' backgrounds, preferred technologies and techniques. It is seen as an accurate view of what is happening in data science based on the volume and profile of responders. Okay, we're using the Cargo 2022 survey data set in this instance. So let's just check that. Data science salaries. Okay. Okay, I think we have that data set. So let's see what it looks like. So it has job categories, relative frequency. Okay. Okay. Let's connect to the data set, data science salaries. And just clean this out of the way. This was for chapter 3 of the course. Our data set is named data science underscore salaries. The data is clean already, so let's see what we have here. Let's just rename it salaries as it is named here. Voila. So we have the data science data set here, just 600 rows of data, cleaned already, and 8 columns. Let's just do dot edge. We have the working year of the respondents, the designation, probably the person is a data science, machine learning specialist, machine learning scientist, big data engineer, product data analyst. We have the experience, the employment status, full time, the employee location, company size, remote working ratio, and the salary in USD. Interesting. Nice data point here. Okay, now it says have a look at the job titles and category to align with our salary data frame. The job titles mm, is called designation here, and the categorize to align job title and categorize. Categorize. Am I having same data set here? I doubt. Let's take a look at another data set that we have here. Okay, hold on a minute. Let's see. Okay, this unemployment data sets, so it is wrong. Let's keep using the data science salary data sets. Okay, so let's do with this for now. Hopefully, it aligns with what we have here. Okay, so thinking of the cargo survey result as the population, your task is to find out whether the salaries data frame is representative by comparing the relative frequency of job categories. Oh, okay. Just want to do something simple here. I understand that now. So print the relative frequency of job categories column from salary data frame. Okay, you want to print the job category column from the salaries data frame. Salaries data frame. Want to print the job category column. Let's see. So the job category, you can see the machine learning, data engineering, data analytics. So this is so we just printed the column from this data frame, this job category column. We're showing just one column out of the number of columns in that file. We have 7 rows of data. Let's submit and see. Ooh, I didn't get it. What was the error? Relative frequency. So I have to print the count. Oh, then I'm going to add the normalize function, the value counts. Dot value counts. So I want to say how frequent each record is in the data frame. The count. Do I have to put normalize? Let's run the code and see. Oh, salary job category dot values. Oh, values, not values, just value counts. Okay. Then the relative frequency it should show us in percentage. I have to put the normalized line of code inside my value counts. Normalize. Normalize should be equals to 2. Now this is going to show me the frequency of those records in the data frame. That's too close. This is better. Okay. So you can see the percentage of data science job category. Look at the accounts here. Data science is over 113. Data engineering is 111. Data analytics 92. Machine learning 49, 28. Data 28 manager is 14. And this is the frequency. Others account for machine learning accounts for at least 12% of the data sets, while data science and engineering account for 27%. So this is not a good representation of the data points. Okay, let's see. Fantastic relative frequency calculation. It looks like data science is the most popular class and has a similar representation. Exactly. Data science. Still, the other categories have quite different relative frequency, which may not be surprised given the target audience is data scientists. Given the difference in relative frequency, can you trust the salaries data from to accurately represent managerial roles? Exactly, look at the managerial roles here. The target audience is data scientists, because the managerial is just 3% of the whole data points, which this data frame is not representing managerial roles enough. Okay, let's see. Cost tabulation. So cost tabulation can help identify how observation occur in combination. Using the salaries dataset, which has been imported as pandas data frame, you perform cost tabulation on multiple variables, including the use of aggregation to see the relationship between company size and other variables. If you want to see the relation between company size, okay, I have something similar here. I can do the same thing for my designation here. I could just see the designation column in this instance. Okay, let's try it out. Let's try it out real quick. Let's try it out real quick. I'll just copy this. Let's paste this here. But before that, let's add the line of code here. I want to print the relative frequency of prints. I could just say print the print out the, let me just say print out the designation category. It's called designation category here. I'll just write to be value counts. Let's take count that we have here. Mm, I'm missing one line of code here. Uh-oh. Job category. Oh, mine is called designation, yeah, not job category. Okay. Designation. Designation. Let's run the line of code again. You can see we still have similar results here. We have a lot of data points here. We have data scientists, account for 153, data engineer, data analyst, machine learning. We have a lot of roles here. Big data engineer, machine learning scientist, principal data scientist, AI scientist, and so many. And let's see the frequency of this in the old data points. Okay, voila. Hmm. As usual, data scientists account for the highest record here. Do you have any managerial role here? There's marketing data and finance data analyst, big data architects, big computer vision research. This will be a good representation of this 3D computer vision researcher. Alright, so that is by the way though. So let's move on. Now it says cost tabulation. Okay, perform cost tabulation setting company size as the index and the columns to class in experience. So cost tabulation. So when you say PD dot cost tab, this is the cost tab function here. So it says set company size as the index. Our company size is going to be the index. Let's copy this company size. Then our experience is going to be column. Okay, now let's run the line of code and see. Okay, cost tabulation, experience at the index. Okay, let me create this in my Jupyter notebook here. Can I just make this sound a little bit smaller? How do I do that? So I say dot add. Let's see if it's going to work here. Mm, okay, it's going to work. Just to see a few rows of the data sets. Dot add. Voila. So I don't have to be scrolling for too long. Okay, print cost tab, company size, we have company size here, and experience. We have experience. You can see the experience here. Mid level. Let's see what the result we get here. Voila. So we have entry, executive, mid, and senior experience. Then the company size is large, medium, and small. So you have in large for entry levels in the large company size we just have 29. So the highest when we look at the senior roles, there are more senior roles in the executive or in the medium companies, and there are less executive roles experience in small size companies. Interesting. That's interesting to see. Okay, so let's move on with our analysis. Now, cost tabulate job category and classes of company size as column names. Okay, doing the same thing, PD, the column the cost tab function. Our data frame is salary data frame. So we want the job category, job underscore category to be our index, column index. Then our salaries data frame. Then this should be our column, company size also. Company size. Voila, you see. Let's recreate this similar scenario in Jupyter Notebook. This time around, we want the designation to be our column, this designation column, to be our index, then the company size. Voila. Oh, this is March. This is March. Designation, we have different rows. Ooh, let me just do dot add also to make it smaller. This is manageable like this. So we can see a couple of rows easily. Then let's submit. So it says we should update PD cost tab to return the mean salary USD values. Ooh, mean salary USD value. Okay. That be the mean salary USD value is probably per what? Per the job category and the company size. Okay. Cost tab, job category, salaries. Our column should be the company size. Then the values is going to be a values calculation for the salaries data frame. Then our salary USD is the column in salary USD. Yeah, the salary is in the column in salary USD. For analysis, let's copy that. Salary USD. Then our is going to be a function of arg function. argfunc. Then it's going to be median calculation. So sorry, the mean. We have to return the mean here. Mean calculation. And let's see. Voila. So you can see the mean salary for each job category by the company size. So I want to return the mean USD. So this time I'm going to be designation instead of job category here. Okay. That's on the line of code. Cool. I see some information are not available for this for the rows. So that means our data set isn't complete. Interesting. Let's do that edge in this instance. Still a few rows of data. Okay. This is here for large, medium-sized companies. This is the mean salary. Awesome cost tabulation. This is the handy function to examine the combination of frequency as well as find aggregated statistics. Looks like the largest mean salary is for managerial data roles in large companies. Let's check. You can see it right here. Managerial data roles in large company. That is the highest mean salary. I mean, this data set is absolutely not clean here. Let me move the head real quick here. Oh, I don't even have managerial in my own data points. So let's move on. Now let's look at generating new features. Probably generating new columns. Quick break, 1 minute break. Let me just check up on important messages if I have one. All right, so let's continue.
Sometimes the format of our data can limit our ability to detect relationships or inhibit the potential performance of machine learning models. One method to overcome these issues is to generate new features from our data. Checking correlation with a heat map, we see a moderate positive correlation between price and duration, but it looks like those are the only numeric variables in our dataset. Viewing the data types confirms this is the case. However, total stops should also be numeric. Viewing the value counts, we see we need to remove string characters and change non-stop to 0 before converting the data type to integer. We use the string.replace method to first remove stops, including the space, so that flights with 2, 3, or 4 stops are ready to convert. Next, we clean flights with 1 stop. Lastly, we change non-stop to 0, then set the data type to integer. Unsurprisingly, total stops is strongly correlated with duration. What is interesting is that total stops and price are more strongly correlated than duration is with price. Let's see what else we can find out. Rechecking our data types, notice that there are 3 datetime variables: date of journey, dep time, and arrival time. We know how to extract attributes from datetime values, so we can see if these offer any insights into pricing. To start, let's look at date of journey. If we think prices vary per month, it's worth using this attribute. We create it as a column in our data frame. Perhaps prices might also differ depending on the day of the week. Let's grab that using the dt.weekday attribute. It returns values of 0, representing Monday, through to 7 for Sunday. Previewing these columns, we see the first flight, departing on the 6th September, was a Friday, indicated by a 4. We might wonder if people tend to pay more to depart or arrive at more convenient times. We extract the hour of departure and arrival from those respective columns too. Because they are numeric, we can calculate correlation between these new datetime features and other variables. Replotting our heat map, unfortunately, there aren't any new strong relationships, but we wouldn't have known this if we hadn't generated these features. There's one more technique we can use to generate new features. We can group numeric data and label them as classes. For example, we don't have a column for ticket type. We could use descriptive statistics to label flights as economy, premium economy, business class, or first class, based on prices within specific ranges or bins. We'll split equally across the price range using quartiles. We first saw the 25th percentile using the quantile method. We get the 50th percentile by calling the median. Next, we get the 75th percentile, and lastly, we store the maximum value. We create the labels, in this case our ticket types, and store as a list. Next, we create the bins, a list starting from 0 and including our descriptive statistic variables. We now call the pd.cut function, passing our price column, setting the labels argument equal to our labels variable, and the bins argument equal to our bins. Previewing the price and price category columns, we see the mapping has been successfully applied. We can plot the count of flights in different categories per airline by passing our new column to the hue argument when calling sns.countplot. Looks like Jet Airways has the largest number of first class tickets, while most of Indigo and SpiceJet's flights are economy. Let's generate some new features in our Data Professionals dataset.
Ooh. So we just use categorical numerical variables to create some categorical columns. Interesting. Interesting. Now let's do the same thing really quick. So extracting features for correlation. In this exercise, you work with a version of the salary dataset containing a new column called date of response. Ooh, I don't have that in my own data point. This is not fair. I don't have a column called date of response here. Working year, designation, experience, employment status, employee location, company size, remote working ratio, and salary USD. But I don't have date of response, so I can't do it. Replicate same thing in my Jupyter notebook here. The dataset has been read as in a pandas data frame with date of response as a datetime data type. The task is to extract datetime attributes from this column and then create a heat map to visualize the correlation coefficient between variables. Seaborn has been imported as SNS, pandas as PD, matplotlib, pyplot as PLT. Okay, so the first is to extract date month from date of response, salaries month, and extract the dates month from the date of response. Okay, get the month of response. So going to be salaries, the new column called months, salaries, then date of response is the column. Want to start the month from that. Then want to start dot dt dot months. Want to start the month. Okay. Now I start the weekday of response. The weekday, similar scenario. Let's change this to, so it's going to be weekday dot weekday. Weekday. Finally create a heat map. Heat map. Okay. SNS dot is that to be east or heat map? That to be heat map. Then the data frame. Okay, data frame is salaries. Salaries. I want to do the correlation. What is the correlation of the heat map? So numeric is going to be 2. Then our annotates is going to be 2. 2. Let's on the line of code. Oh, so my heat map is now showing very well here. Let me see if it's going to show if I reduce this to 100%. Oh, not showing. That's my heat map pretty well here. What if I try to open it in a new tab? Ooh, similar scenario. Slides in rupee. I see the heat map is pretty small. Uh-oh. Okay, let's submit and see. That is go better. Yeah, it's not showing pretty well now. So you can see this map here. Oh, voila, this is better. So this is about its map. You can see this correlation. There's not much correlation here. So you see the line of code. So the closer to 1, they are the correlation. You see the weekday. There's some correlation between weekday, each weekday and weekday. Those are not the points you want to look like. Salaries in rupees, salaries in rupees. When you check this one here, this darker side, this is getting negative. There's less correlation there. Coming for the lighter end, that is closer to 1, there isn't much correlation between these data points here. So let's move on though. So fantastic feature creation. Looks like there aren't any meaningful relationship exactly between our numeric variables. So let's see if converting numeric data into classes offer additional insights. So you can see that there are no relationship between those numerical variables because it is just too darker. Let's convert those into our categorical variables. Okay, we're definitely going to create a couple of new columns real quick. So let's do that. So find the 25th percentile. Pretty straightforward. So 25th percentile is going to be the salaries column, salaries data frame, salaries data frame. For which price? For the salary USD column or the salary USD column. That will be the quantile. We're going to use the quantile function here. Quantile. Then that will be 0.25 for 25th percentile. Salary median, pretty straightforward also. It's going to be mean. Then gather the 75th percentile. I just copy this. I change this one to 75. So print 25th, median, and 75th. So you should have our results here. You can see. So you can see them there. So let's continue. Uh-oh. What's with the error? Median. Oh, median, not mean. The median, not the mean. I was printing the mean instead of the median. Also be median, not mean. Okay, we've done that. So categorizing salaries. Now it is time to make a new category. You use the variable 25th, median, and the 75th that you created in a previous exercise to split salaries into different labels. Okay, now let's use that one to split it into different labels. But first, we need to create a salary label, a list containing entry, mid-year, and executive. Oh, interesting. I could have easily created this thing in my data frame here, though. Is that possible? Or let me see if I can do that. Since the first scenario I created here isn't making sense. Hold up a minute. Let's go backwards. So this data response, I couldn't do this in my data frame here because I don't have access to these dates columns. I don't have access to this dates column. Doesn't mean I can't create a new scenario. Okay, let's continue though. Okay, I try to create this for the salary USD column. Let me go ahead and create this in my own Peter notebook too. You can say, oh, good, I have access to this. Interesting. Hello, one, two. Okay, just save this somewhere to make this line of code more understanding. Oh, okay. Now we have this line of code here also. Also, let's continue and see. Okay, it says now categorizing salaries. I want to categorize the salaries in this instance. So now it's time to make a new category. You use the variable we've created and You are going to create previous exercise to split salary into different labels. We want to create them into different labels. But for that, we need to create a list of our salaries. Create salary labels, a list containing entry. Salary label is going to be a list containing entries. I'm going to get rid of this and keyword here. So we have our list already and get rid of this full stop there. Okay, let's do that here also. Mhm. Okay, we are getting there. Let's run it. Finish the salary range is adding 25th percentile, median, and the largest value from salary USD. So now is to finish this. So our label is created. So let's create the salary range list. Salary range list going to be 0, then the 25th percentile. Ooh, what is this line of code here? This last line here, what could that be? Okay, let's add this. Just copy them from here. 25th. Oh, how many commas am I having here? Hold up, hold up a minute. Okay, then the next one is salary median. Salary median. The last one is 75th percentile. Then the maximum value 1, 2, 3. What's the maximum value from salary USD? We could do the okay, that should be straightforward. It should be salary USD, the salary data frame, the salary USD column. Okay, salary USD column dot max. That should give us our results. Okay. We got that. Let's run the line of code. Voila, no error. That's interesting. Yes, we nailed it. And let's create the same thing here also. Salary ranges 25th, this, and that. Let's run the code. If I call on salary ranges, I should see the range of the salary, hopefully. Well, I see. So this is the salary ranges from 0, 25th percentile that we created here. Salary median, this right here. Then 75th percentile, this right, and the highest maximum value from the salary USD column. This is it right there. Okay, we are getting there. Okay. So now split salary USD based on the labels and radius we've created. Okay, now we have to split the salary based on the radius we've created. Okay, salary level. Hit a salary level column. Salaries, salary level new column. So it's going to be PD dot cuts. PD dot cuts. Going to be salaries column. Salaries column. There were new one. Mm, Hold up a minute. Salary level, salaries. Then the salary USD column. Salary as a column. The beans is going to be our bean. What's our beans there? So our beans is going to be these salary ranges for the splits, salary ranges. Then our label is going to be our salary labels. Salary labels. Let's run the line of code. Voila, we've done it. Let me just run on the copy this, okay? Create salary level. Copy this right here and paste it here. Voila. So our new column salary level is created based on those information. Submit and see. Use SNS count plot to visualize the count of company size, factoring salary level labels. Ooh. Let's complete the last line of the action. Now let's just do something real quick. Salaries. If I call on salaries now, dot add. We should have a new column there called salary level. Let's see. Let's see now. We have it here. Voila. This is salary level based on the salary as a column. But we have that already here. Experience. This is experience level. Experience level. But this is salary level now. Interesting. Let me just call on two line there. Interesting. Now let's create a visualization for that. It says use sns.count plots. sns.count plots. So our data frame is going to be the salaries data frame. To realize the count of company size, factoring salary level labels. Company size, our variables company size. We want to use the salary labels, salary level, salary level. Let's copy salary level right here. Let's see. Oh, voila. Interesting. See the salary levels. So it's small, the medium, the large. Let's do the same thing here. Let's create it here. And voila. We have our visualization. Interesting. Based on the what? Salary level that we just created. So we could see the company size based on salary level. We see the medium company size as more senior salary level compared to the large company size and the small company size. Mm. Even in general, the medium company size has a larger percentage of salary levels across all the categories of salary level. Ooh, nice calculation there. Nice work by using the PD code to split the numeric data into categories. You can see that a large proportion of workers at small companies get paid entry-level salaries. You see, it says a large proportion of workers at small companies, yes, get paid entry-level salaries. You can see them here. They get paid entry-level salaries. Small companies, they get paid entry-level salary compared to other high-level salary, which is very, very bad. While most staff at medium-sized companies are rewarded with senior level salary. Medium companies, senior level salary. You see that? And finally, now let's look at generating hypothesis as we reach the end of the DA phase. Ooh, interesting. So finally, let's look at the last part of the lesson, generating hypothesis. So what is going to be our hypothesis for this challenge so far? Quick break. Okay, so let's finish this
Generating
first.
hypotheses is a fundamental task for data scientists. Let's look at how and when this is done. It's reasonable to feel like we have a good idea about our planes dataset at this point, right? We've explored our data extensively and even generated new features to get new insights. We know that a large proportion of Jet Airways tickets are expensive, as we labelled them as first class. We also know that duration, total stops, and price are all moderately correlated, but no other meaningful relationships exist. But if we generate a scatter plot of price versus duration, factoring total stops, it looks like total stops largely depend on duration. This is an example of a spurious correlation. We might think that total stops is correlated with price, but in fact, it's just duration that is correlated, and total stops mostly maps to duration ranges. Also, if we split out the number of stops to look at correlation individually, it looks like 0 stops has a strong negative correlation with price, but there's no meaningful relationship for journeys with 3 or 4 stops. When performing EDA, the question we should ask is how do we know what we are observing is true? For example, if we collected new data on flights from a different time period, would we observe the same results? To make conclusions regarding relationships, differences, and patterns in our data, we need to use a branch of statistics called hypothesis testing. This involves the following steps before we even start collecting data: coming up with a hypothesis or question, and specifying a statistical test that we will perform in order to reasonably conclude whether the hypothesis was true or false. Let's imagine we work for an agency regulating airlines. So we have our planes data available as part of our day-to-day work without any specific questions in mind. We might be thinking, well, we have all this data, so why not just come up with questions and run some tests now? But we didn't collect the data with the aim of answering these questions. Plus, we've already looked at the data extensively and generated new features, so we might be biased and generate hypotheses that we are confident exist to prove ourselves right. We could also be tempted to run lots of tests, since we have lots of data. The acts of excessive exploratory analysis, the generation of multiple hypotheses, and the execution of multiple statistical tests are collectively known as data snooping, or p-hacking. Chances are, if we look at enough data and run enough tests, we will find a significant result. So how do we generate hypotheses? We perform some EDA. Say we think that, on average, Jet Airways flights last longer than SpiceJet. We can create a bar plot which shows us the mean duration per airline. Or we might have a hunch that flights to New Delhi are more expensive than other destinations on average. Again, we can plot the data to see if this seems to be the case. From there, we need to design our experiment. This involves many steps, such as choosing a sample, calculating how many data points we need, and deciding what statistical test to run. The steps involved in this process are outside the scope of this course, but hopefully, we now have a sense of the advantages, limitations, and overall remit of exploratory data analysis in the data science workflow. Time to practice generating hypotheses.
Okay, let's generate an hypothesis based on what we've learned so far. Uh-oh. Okay, comparing salaries. Exploratory data analysis is a crucial step in generating hypotheses. You've had an idea you would like to explore. You've you've had an idea you would like to explore. The data professionals get paid more in US than they do in Great Britain. You need a subset. You need to subset the data by employee location and produce a plot displaying the average salary between two groups. Okay. The salary data frame has been imported as pandas data frame. Definitely we have a location column in our data frame here. We have a employee location. You can see, yeah, we have that. Let's see what we can do with that information. So filter salaries where employee location is US or GB. Ooh, let's do that. So US and GB salaries, location. Mm, okay, salaries. Where employee location. Let's see. Dot is going to be a filter. So what filter will I use there? Or GB. So US and GB as employee location. So go to employee location. Dot is in. That is in function. US or GB to do that. Voila. So let's do that in my Jupyter notebook here too. And see. So I should call on US and GB. It should give me a subset of the data set for employee location US and GB. Let's see. Voila. You can see only for record for US and GB. Interesting. Because you only have data for what US and Great Britain. Let's see Great Britain and US. Now see what if I remove the head, let's see how many rows of data is that? Just 300 rows of data and 9 columns. Interesting. Okay. Now it says create a bar plots of salary. CNS does bar plots. Bar plots. So our data frame is going to be the US and GB data frame. US and GB. And our X variable against employee location. Let's see. Voila. You see? Let's see the same results here. Ooh. Let me switch it to each other. It will be salary in USD, employee location should be on the x-axis. Much more better. But definitely we'll say those in the US earn more salary compared to those in Great Britain. Uh-oh. Well, I'm not showing it better. Nicely done, but subsetting the data, you were able to directly compare salary between the US and Great Britain. The visualization suggests you've generated a hypothesis that is worth formally investigating to determine whether a real difference exists or not. Okay, let's see. Now, let's create choosing a hypothesis. You've seen how visualization can be used to generate hypotheses, making them a crucial part of exploratory data analysis. In this exercise, you generate a bar plot to inspect how salaries differ based on company size and employment status. For reference, there are four values. Value meaning, okay. Produce a bar plot comparing salary USD by company size, factoring on employment status. Oh, as you. Okay, a bar plot, SNS the bar plots. For that, our data is going to be salaries, data frame, comparing salary in USD on the y-axis, and the company size on the x-axis. We're going to factor in employment status as the yield. Voila. Let's see it in a much more better view here. Company size, employment. We have employment status there. We have employment status, company size, salary in USD. Let's see. Oh, employment status, full-time, contract, part-time. Oh, I don't know what this F is referring to. Let's see it here. Okay, FL is freelance or freelance, contractor, part-time, and full-time. So if we suggest that, what does that mean? So it says, what is the reasonable hypothesis generate based on these plots? Hmm. Let's take a look at it. On average, small company size employ contractors more. You could say that's okay. How about large company size contractors? How about medium company size full time? Okay, let's look at the option we have here. It says, what is the reasonable hypothesis to generate based on this plot? On average, small companies pay part-time employees less than large companies. Small companies pay part-time employees less than large companies. Hmm, you could say that. Or freelancers earn more at medium-sized companies compared to small or large companies. Freelancers earn more at medium-sized companies compared to large and small size. This is quite similar. Okay. On average, large companies pay contractors more than medium-sized companies. Large companies pay more contractors more than medium-sized companies. Mhm. That's not fully true. Freelancers only work at medium-sized companies in the data sets. Freelancers, oh, since they're not paying for, you can see the amount. So what about small-sized companies? Freelancers are also work here. Good. They don't even work. You see that there's no plot on the bar. Okay, that's true. Mm, that's correct. Excellent. Contractors appear to be paid more by large companies on average based on the data. That's a reasonable hypothesis. You see, contractors contractors in large companies earn more than medium-sized companies. You can see it here. Contractors earn more than medium-sized companies. You can see the data says here, all these are not getting paid. This they don't have bar. You can see that freelancers only work at medium-sized companies. Exactly. Oops, interesting. Okay, I think the
Congratulations
next
on
one is
completing the course. You've covered a lot. You started off by learning how to inspect and validate data before performing aggregation and calculating summary statistics. You saw how to check for missing values. You then identified strategies to deal with it, including dropping missing values and imputation. You discovered how to create categories from strings. Use lambda functions to conditionally calculate summary statistics based on categories and add values into the original data frame, and deal with outliers. You progressed to examining relationships, including patterns over time, correlation between variables, and interpreting distributions. In the final chapter, you learned the benefits of cross-tabulation, generated new features using pd.cut, and saw the impact of data snooping. You finished by identifying the limits of EDA and the next step of the data science workflow, hypothesis testing. Now you understand EDA, you may wish to explore some courses that build on the concepts in this course, such as the steps involved in hypothesis testing, or supervised learning, which is a form of machine learning. We hope you've enjoyed the course and feel confident in performing exploratory data analysis going forward.
wow, interesting. Especially data analysis is quite wide and large. Now the next one I think is sampling in Python. Oh, we have a project analyzing crime in Los Angeles. That'll be our next project. Interesting. Let's get our hands dirty. The project is going to be interesting. Ooh, explore crime CSV data set and use your findings to answer the following questions. Interesting. So that'll be our next project. Let's go. All right. So that'll be the live stream for today. If you want to join me in my exploratory, in my next project, which is the exploring analyzing crime in Los Angeles, I'll see you on the next live stream, which is tomorrow, day 71, as we look and tackle this crime data set from Los Angeles. Bye for now. I will see you in the next video on the channel, and have a wonderful rest of the day.